Hope everybody is doing alright today. We're going to look at Pythagorean theorem. The objective today will be to solve for a missing side using the Pythagorean theorem. Pythagorean theorem is something you guys probably have heard of before, whether it's from a brother or sister or maybe even in middle school. Pretty simple concept, and I'll show you exactly where it comes from. So if we have a right triangle, so it has to be a right triangle, it's the only time it works, we want to use the Pythagorean theorem. What it says is if we take the square of one side of the triangle. So if we have, for example, 4 units squared, that would be 16. Plus the square of the other side, which would be 3 squared here, that's 9. That's always going to equal the third side squared. So in other words, 16 plus 9 is 25. A squared plus b squared equals c squared. Now, c always has to be the side across from the right angle, or what we would call the hypotenuse. So again, Pythagorean theorem is a squared plus b squared equals c squared. And we're going to be able to use that to solve for a, b, or c. It depends on what side we want to go for. So if we look at a couple examples, I'm going to have you guys do a few of these here in a second. What we want to do is always decide which side c is. Now you might not be given c as a variable, so I might sometimes give you, this is x, and if you saw that was an x, you still want to identify that this side is in fact c. It does not matter which one a and b are, you can pick. It really does not matter. So what we're going to do here is it's going to become 3 squared plus 4 squared equals c squared, and then you will simplify. So it becomes 9 plus 16 equals c squared, 25 equals c squared. To get rid of a square, you square root. Square root of 25 is 5. So that third side, or the hypotenuse, would be 5. Same idea number 2. I would like you guys to try number 2. A squared plus b squared equals c squared. Make sure you know which side c is. I will do example 3, and then I'll have you guys do example 4 again. So again, make sure you know which sides are a, b, and c. Go ahead, plug everything in. 3 squared plus 9 squared equals c squared. 9 plus 81 equals c squared. So we get 90 equals c squared. Now this is what we talked about on Monday. I want exact answers. In other words, I do not want you to take the square root and come up with a decimal. What you need to do is your factor trees. So yes, you're going to take the square root, and now you're going to start breaking this up. 9 times 10. Break that up into 3 times 3. That can't go any farther. Make that break up into 2 times 5. Circle your pairs. There's a pair. And then you have a 5 and a 2 that are going to stay inside. If they do not have a partner, they stay inside the radical. So we have a pair of 3's. They come out as a 1. The 2 and the 5 stay inside, so that would be 2 times 5 is 10, and that would be your final answer. So all the radical rules we practiced today, or if hopefully you're watching it on Monday night, all the rules that we practiced on Monday are rules that we will apply. So no decimals. Make sure you are factoring using your factor trees. Okay. I would like you guys to try example 4. Looking at example 5, we have, again, A, B, C. Make sure you know which side is which. So it's going to become z squared plus 7 squared equals 15 squared. So that's z squared plus 49 equals 225. 225 minus 49 is going to give you, let's just double check that, 176. Again, take the square root. See if it works out first. So square root of 176 is going to give you a decimal. You'll find out when you check that. So you know you're going to have to factor. So you got to figure out what that breaks up into. So 176, let's see. That should be divisible by 2 for sure. You want to try and go for high numbers, but let's look at 2 first. So that would be a 2 times 88. Can't go any farther with the 2, so leave it alone. That's going to be, you could go 8 times 11. 2 times 4, 2 times 2. You have a pair of 2's there, another pair of 2's, so that's two 2's coming out. 11 stays inside, so you're going to have z equals 4 times the square root of 11. And that would be your final answer. So again, everything that you have multiplies because they'd be right next to each other. So the 2's come out and they multiply. The 11 stays inside and there's nothing to multiply it with. Let's look at 6. It actually looks harder. It'll probably be easier. And I'll show you why here in a second. So we have a, b, c. So we're going to have the square root of 2 squared plus 5 times the square root of 3 squared equals x squared. Okay, a square root and square are opposites of each other, so what we're going to see happens is a square root and a square cancel, so we're left with just 2. Plus 5 squared is 25 times, again, the square root of 3 squared is just 3 equals x. I'll make that x squared now. So we have 2 plus 75 equals x squared. 77 equals x squared. Factor. Take the square root and then you're going to have to factor, and we'll see what happens here. That breaks up into 7 times 11. Can't go out down any farther, so those actually go back inside, meaning that you just leave this answer as x equals the square root of 77, and just leave it like that. Okay, a couple more examples. Example 7. We have a, b, this side is c. So again, I'm just going to put this in blue so we don't get mixed up with the one before. We have 9 squared plus x plus 7 squared, the whole thing squared, equals 15 squared. So that's going to become 81 plus, do it like this, x plus 7 times x plus 7. That is how you want to multiply that, equals 225. Okay, that's going to be a foiling problem. You cannot just do x squared plus 49. That will not get you the right answer. So we're going to have 81, and then we're going to FOIL, plus x squared first, outer, inner, last, equals 225. So we have 81 plus x squared plus 14x plus 49 equals 225. Okay, so we're going to have to FOIL, and then we're actually going to go backwards and going to have to factor here in a second. So let's combine the left side what we can. So we have 81 plus 49 is going to give us 130. So x squared plus 14x plus 130 equals 225. And now we see we have an x squared and an x, so we actually want to move that 225 to the left side. So we're going to subtract. So we have x squared plus 14x minus, let's see, 130 minus 225 is going to give us negative 95. Okay, so now we're ready to go ahead and factor. So let's take a look at this. We have x plus some number times x minus some number equals 0 because we have to get to a negative multiplication. So you might just have to play with some numbers. So let's see. If we do maybe 19 times 5, okay, you get pretty good at this after a while. That works. So we have x equals negative 19, x equals positive 5, and we're going to go ahead and see which ones work. If you plugged in negative 19 to that bottom side where b's at, you would get negative 12. Doesn't work. If you plugged in 5 there, you would have 5 plus 7 is 12. That would work. Here, you could check your answer by doing, okay, 9 squared plus 12 squared, is it equal to 15 squared, and it would work. So you just have 5. So same idea, you just have to make sure that you are multiplying x plus 7 squared correctly. You're foiling that. Moving on. Okay, so we have another one, example 8. Again, you have A, B, and C. I want you guys to try this one for tomorrow. So you're still foiling. I'll check to make sure you've had the ones that I've highlighted so far. Example 9. Okay, this is one that's a little bit trickier. You have a few given sides, and you're going to have to figure out what x, y, and z are. Okay, so you have a right triangle on that right side. That's the only right triangle that you're given for now. You also know that this is going to be a right angle, which might help you here in a second. You have two sides. You want to find a third. The third is 10, and that's the hypotenuse. It's across from the right angle there. So we're going to start off by doing a squared plus b squared, which is y in this case, equals 10 squared. So we have 36 plus y squared equals 100. And I think a lot of you guys that are pretty systematic will like Pythagorean theorem because it's very similar steps every single time. So we have y squared equals 64, so y is 8. So what we can do now is say that this side, instead of being b, let's just make sure that this side is 8. So we have y is 8 so far. Now if you know y is 8, you can also figure out z. If the whole thing is 40, 40 minus 8, that's going to make z 32. And now you can figure out, okay, in order to find x, I have 6, I have 32, find x for me. So I want you guys to make sure you finish example 9 just finding x. I already found y and z for you. Make sure you find x by using your Pythagorean theorem. So that's Pythagorean theorem in a nutshell. What are we looking at? What we're trying to find, we have two sides, we want to find a third side. We can also use Pythagorean theorem to decide if a triangle is right, acute, or obtuse. In other words, what kind of angles does it make? Okay, and our basically formula, if you want to think of it as that, is this. If a squared plus b squared is equal to c squared, which is the formula we talked about at the beginning, it's going to be a right triangle, which makes sense. We talked about that at the beginning. That's what we're looking for. If a squared plus b squared is greater than c squared, it's acute. And then obviously if a squared plus b squared is less than c squared, it is obtuse. I'll give you a little visual on this tomorrow, how you can remember which one's acute, which one's obtuse. Obviously you're right, it has to be equal. So first thing you want to do in examples 10 through 13 is decide, okay, do we even have a triangle? In order to have a triangle, you need to make sure the two smaller sides are bigger than the third side. Your third side is always C. So what I would do on this one is always go ahead identify which side should be C. Okay, always the biggest side. Now, do A and B, are they bigger than C? If they are, you have a triangle. If they're not bigger than C, and if you think about it like this, again, if you have like 3, 3, and this side is 8, there's no way you could have 3 and 3 meet. They're going to fall right on top of 8. Kind of like almost like a drawbridge if you think of it like that. And they're not going to meet. You need them to be bigger than C. Is 7 plus 12 bigger than C? Yes. So now what you're going to do is go, okay, 7 squared plus 12 squared equals 16 squared. And we're going to see how it works out. So 49 plus 144 equals 16 squared is going to give us 256. So 49 plus 144, 193 equals 256. So a squared plus b squared is less than c squared, which tells us, okay, it is obtuse. And now we are done. Okay. Example 11. We see we have 2 plus 3 is 5. 5 is not bigger than 7. So this is not even a triangle. So stop there. Do not go any farther. You can't decide if it's right, obtuse, or acute because it's not even a triangle. I'd like you guys to do the same thing on example 12. Again, you're just trying to find out which one's the bigger side, and then a squared plus b squared equals c squared. Decide is it right, acute, or obtuse. 14, this one's going to be for tomorrow at the beginning of class, so make sure you guys are ready to go. You know what you're doing, and you can help your group mates out tomorrow. See ya.